Hi guys, welcome. In this video, we are going to look at a project management case where the activity durations are not known by certainty and they are represented by random variables. And each activity duration is going to be represented by a triangular distribution. So if you do not know what a triangular distribution is, it is going to have a shape like this, and the activity duration could be anything in this range. And what we call here is that the lowest value as the optimistic value, that task duration could be the lowest or most likely, and then the highest. It is going to be very low probability for that activity duration to be in either and A or B, but it is possible. But there is no possibility going outside of these ranges. If you represent the random variables of these durations with normal distribution, you are not going to be able to create a distribution with not symmetrical distribution. You may have to use a beta distribution, and that's another alternative, but the easiest distribution is the triangular distribution. So how are we going to create some random variables for every activity? Then if we do that for a longer or larger number of values and simulate that, we would have a better understanding of the project duration. So let's just copy this here and take that and paste that into Excel, okay? And what we need is we have a cumulative distribution function FC there, and that is the value that we are going to be just using. And we will just create the random numbers using this information provided here. So what I'll do is, let me just, I'm just going to pause my video, and then I will just enter this function for the random duration to save time. But I would recommend that you also pause your video and think about how you would be able to implement this. The one thing that you are going to be doing here is that the U here is going to be drawn from a uniform distribution, and between 0 and 1, then you could easily do using the rand function. So in that case, if what we're going to do is, if U, whatever U, that the random number that we generate, if that is less than FC, which FC is C minus A over B minus A, then we are going to just use this equation. Otherwise, we are going to be using this equation. We know that this U is going to be between 0 and 1. Let's just do that together, and without, maybe I don't think this is going to take too much of a time. Okay, so in that case, I'm going to just say that if, so the U is my random number, okay? And if U, which is rand function, as you realize that the rand function is going to generate, let's just do that in here, is going to generate a number between 0 and 1, and I can refresh that. So as you see here, and by pressing F9 on my keyboard, if you have a laptop, maybe a function and F9 is going to just create a random number, a uniform random number between those two values, 0 and 1. So in that case, I'm going to just say that if rand function is less than, okay, and C is what I call here as M, the most likely value, so A and B are the same values, then I would just put my function here, then I'll just continue with that. So I'm going to pause my video, you just pause your video as well, and try to put that function in here. A is A here, okay, so you're going to refer to A, and B is B, and C is actually represented by M. If you want to just change it to C, that's okay too. So most likely is kind of a typical representation in project management literature. Okay, this formula is ready now. So if you take a look at it, what we are doing here is, if the U value, the random function, is less than C minus A over B minus A, then the result is this part of the function, and otherwise the result is that part of the function. And let me just open that for a while for you. You can pause the video and take a look at it. Make sure that your parentheses are in the correct places. And this is going to be just your function there. So when you have that, and if you press F9, and you'll see that it is just generating a random duration between 4 and 10. And if you take all these random durations and put them in a certain column, you would realize that all those random durations are going to turn into a triangular shape. So if I want to do that, what I would do is, let's just do it here in another column to see that, and just to display it, and after that we'll just delete it. So what I'll do is, I'm just going to just come here and just call it trial, and then duration, and trial is going to go from 1 to, let's say, 1000. And to do that, I'll go to the series here, and in a column, and stop value is 1000, and I click OK. So these are my trials, and I'll have my duration. Let's just take this and shift them one level below. Control Shift and down arrow will just highlight everything. And here I'll just reference to this cell here. And then this is my formula, and this is my duration. I'll highlight this top part, and Control Shift and down arrow is going to highlight everything in the range. And then I'll go to my data and the what if analysis data table. And I'll click on in the column input cell and click on any blank cell. And I'm just going to click on this blank cell here. So the reason for that is, usually this data table is used for when you have a sensitivity analysis. So when you have like certain value changing your model, and how does that change your output? And you could just use the data table approach. But right now there's nothing that we are changing. We just want Excel to refresh itself 1000 times and create us 1000 random numbers. So in that case, because there is nothing, no input cell to change this, it's just a random process, I'll just click on a blank cell and then click OK. As you see here now, let's just take a look at these durations and maybe look at what kind of a histogram they have. And you realize that the histogram is going to look like something in between 4 to 10. And it is somewhat having a triangular shape. So if I just increase the number to 10,000, and it is going to look more like a triangular shape. 100,000, 1 million, it is going to look exact, very smooth triangular shape. So if I change, for example, make that not 4710, but 4715, as you see here, it is just going to change its structure. And if I change it is to like back to 10, and this is the way that it looks, okay? So in that case, we are able to get our random durations, and we'll do that for the project durations. So in that case, let's just keep this here for now. So instead of the project, this activity's duration, we're going to use the project's duration for that. And let's just double click on these random durations. And now we have a duration for every activity, and each one of them is a triangular shape. And a lot of triangular shapes, if you put them together, convolute them, they are going to have an approximate normal shape when you just put them together. What we are doing here is that we are putting these activities durations together, but not all of them. We are putting the ones that are on the critical path. But the issue here is that the critical path changes, right? So why does it change? Because the activities have random durations. That's why. And sometimes one activity may become an activity on the critical path. Sometimes another activity may become on the critical path. So let's just then maybe find the project duration. The best way to find the project duration is just finding the early start, early finish, late start, late finish values. And to do that, we will just start with activities A and B. They don't have any predecessors, so their early start values are 0. Okay, and each time I press, I just put on any cell, I just put a value that it just refreshes itself. That's okay. And then the early finish values are whenever you start the activity, the finish is going to be the start, early start plus the duration of that activity. So the early finish values are always going to be the same function, the formula. So it is only going to look at the early start, and then you'll be able to find the early finish by just adding the activity duration. But the early start is kind of tricky. Here I need to look at which activity comes before that activity. So C, for example, comes after A and B, and whichever A and B, whichever is finished later, then we can start C by that time. So if this is the situation here, we are not going to be able to start C by 5.27. That is going to be has to be 6:32. So the reason for that is I'll have to wait for both A and B. It's like you are going to look for two things before you start another activity. Maybe like if this is a construction project, you need to wait for the plumbers and also the electricians do their job, and after that maybe you will just go and do the drywall. So that's a possibility here, maybe an option to, a scenario to consider. So the C is going to then come maximum of this 2, and that's C, and D comes after C. So D can just start as soon as C is completed, and then E is going to start after C as well, so as soon as C is completed. F is going to start after E, and then G is going to start after C. And Excel is warning me that why did you put those durations, and it's okay, Excel, so I'm not making any mistake there. And then H is looking for D, F, and G, so I'll have to just maximum of the early finish of D, F, and G, okay? And then I is going to look for G and F, maximum of G, F, and G. And then J is going to look for H when H is done. And then K is going to look for I and J, so the maximum of I and J early finish values. So we're done with the project duration. So we are now able to find our project duration, and the project takes 77.44, or the project may take 68, or the project may take 67. So the project is going to take something in that range. Okay, that's the project completion time. We want to see the distribution of those project completion times. But before that, just stick with me. Then we'll have to let's also put the late start and late finish values as a practice. And because we just want to see how the critical path changes when the simulation is running. So the late finish value for the project is going to be calculated or just determined by looking at the latest activity that doesn't have any follower. So if there are more than one activity that doesn't have any follower, then we would have to look at their early finish of either one of them, and whichever comes later, then that is going to be the project completion time. So in here, the K doesn't have any follower. That means K is the latest activity. There are no other activities that are coming after K, or another activity which doesn't have any follower. There is none. So that's K. So the K in that case, the late finish of K is going to be the early finish of K, which is the project completion day. And after that, I'm just using formulas, so I don't care about the numbers for now. The late start values are going to be, when I know when do I finish, then I'll be able to know when I start by just subtracting the duration of that activity. So the duration of that activity is this random duration. So this is going to be always correct. So if I know when to finish, then I would know when to start. And usually this is called a forward pass, which we were able to complete it from the beginning to the end. And this is called a backward pass. So we're going to just continue from back towards front. But for the late start, we could just drag this and just put the formulas in, but we'll have to put the late finish values in order for these numbers to be correct. So in that case, I'm going to just do a different approach here. So what comes after J? I'm looking at that. So I'm seeing that K comes after J, and I'll make that equal to the K's the late start time. So the reason for that is I can delay the finish of J until the start time of K, and it is not going to delay my project. Okay, so that's then, and I'll just put that. What comes after I? So K comes after I as well. And then I'll see here what comes after H. J comes after H. I'll put that there. And then what comes after G? What comes after G? H and I are coming after G. So there are two. So in that case, I'm going to take the opposite approach here. I'm looking at H and I, so there are 38 and 43. And what I would do is I would say if I just delay G by 43, and I wouldn't be able to H and I, these are here, I wouldn't be able to start the H on time, right? So these are the finish times actually, these are the start times, so 29 and 34. So not 38 and 43. So I would look for these two activities, and I would have to just base myself for the start time of H, not I, because if I just start at finish this by 34, I wouldn't be able to start H on time. So in that case, I'll just take the minimum of this 29 and 34, and this here that I'll take F is the same thing, H and I. That's going to be the minimum of H and I. And then I'll take here E. It is F. I'll take a look at the late start of F. And then D. I'll look at the late start of H. And then I'm almost done. I'll look at C. And C, there are three followers, D, E, and G. The minimum of D, E, and G, D, E, comma, G. And then I'll have B. B, there's follower is C. And then I have A. And then the follower for A is also C. Okay. So let's just maybe take these numbers, and instead of just having a lot of decimals in there, just decrease the decimals to 2 decimals. The same thing that we could do for the random duration, and just to display them with only 2 decimals there. So these are my random durations, and this is my project. And the slack times are going to be just the late start minus the early start, or the late finish minus the early finish is going to give us the slack. So if there is any change, flexibility on the early or late start, then we'll have some flexibility on the start times. What we're going to be calling that as the slack. So the late finish minus the early finish is going to be my slack, or you can just do the late start minus the early start. And I'm not sure why there is a line put there. Okay, so because of my conditional formatting there. Okay, so it looks like I kept the conditional formatting there, and here we have the slack values. So if you want to just remove the conditional formatting, you can, but let's just keep that there. And we would know that if an activity does not have any slack, that activity is going to be a critical activity. So we can also put another conditional formatting there, and we can just highlight the cells if they are equal to 0. Okay, so here the activities are the critical activities and these ones are not, but the things may change. So I will just press on F9 and I see that my critical activities sometimes change, right? So, and the slack durations change. I want to be able to see this in my simulation. So instead of just looking at this simulation for the durations of this only one activity, I'm going to use my simulation for the project duration. And the project duration simulation is going to be then just the latest activity. When it's done, it's either the early finish of that activity or the late finish of that activity. So it is going to be just one of them. And then I am now able to find my project duration simulated for 1,000 times. Let's take a look at how that looks. And as a histogram, as you see, it has a better shape. So it is like more normal shape because we just added a lot of triangular distributions together. And this also changes with every simulation. But what's happening here is that it has a much smaller standard error in here. So why is that? Because we are having the numbers are now just added up, and there are 1,000 of those. And for the project durations, the project duration is not going to have a lot of variability in there, but we would be able to understand if the project duration ever goes beyond a certain number. So let's take a look at here and maybe create our own chart with our own bins, okay, the ranges. So I'm going to just say that from and then to, and then I'll say maybe from, I want to look at if there is any project duration from 60 to 65. And from then 65 to 70, or we could just make it even smaller than that. So 63, and then 60 to 63, and maybe 63.1 to 66, etc. So let's just make this go up to 87 and go take this and go up to 63 and 66, 90, and maybe put one more value, 90 to 100. And then we'll look at the frequencies of this. And to find the frequency, we'll just highlight this range, and then we'll just make that equal to. And we'll just use the function frequency. And the data array is this data array. We'll put our $signs on it, okay, so that it doesn't move down when I copy that down. There's no copying, but I think we're just copying that to a certain number of cells altogether. So it's an array function, and the bins are going to be just these cells. And then I'm going to close the parentheses, Control Shift and Enter, and I have anything above 90 or more. Let's just put that as more, and this is going to be my my frequency. So I'm seeing here now that these are the frequencies, and from to, let's see if Excel is going to be able to just put as a recommended chart. Somewhat like that. No, I didn't like that. So I'm going to maybe highlight this only, and that recommended charts. Okay. So it makes sense here that we are seeing now the frequencies of these observations for the project duration. So it's very likely that the project is going to take about 78 days and maybe even up to 81 days. So there is still 145 out of 1,000 observations fall in that range. But then you are seeing that it is then becoming very, very unlikely for the project to be over than a certain value. So in here, we are seeing that the project 87 and 90, there's only one observation. 90 or more, there is nothing. So I'm going to just maybe F9. And I'm seeing here, rarely do I see anything that's larger than 90. And this is even, I think it's not here. Possibly this is not going to be larger than 90. I think this is over 87 to 90 possibility. Let's just take a look at here in this case. Let's see if there is any number that is, let's see what's the largest number in the durations. So the largest number is 82. Let's try one more time. Okay. Yes, it's not 90 or more. It's my bad. So the function works in this way. I think this is not going to be from to 2. This is up to. Okay. So this is up to, and you can delete this part. So this is up to 60 and up to 60, from 60 to 63 and 87, and this is up to 90. And it's above 87, but up to 90. You can maybe just structure that, and this is going to be just the distribution. So however we're going to determine the project duration in this case, we would maybe just put somewhere around like up to 81 or 84 as a possibility as our project duration. We could just maybe leave about 1% chance and just then assume that the project, worst case, may take around, let's say, 87 days or 84 days in that range. That is going to be your own judgment. That is the end of this project management simulation, and thanks for watching.